Today we will discuss about the second part of this interesting topic, that is polynuclear aromatic hydrocarbons. So in the last lecture we have seen about the introduction about this polynuclear hydrocarbon, so how it is prepared, the structure, and why it is called polynuclear and everything. And today we will discuss more about this polynuclear aromatic hydrocarbon, which is a PAH. So this is the isolated PAH we will see today, how it is synthesized and their reactions, their properties. And then we will go on to see about this fused PAH. So in the last class we have seen the isolated PAH, that is the diphenyl methane, right? It contains two aromatic groups, two benzene rings. So in this class we will start with this isolated PAH, that is triphenyl methane. So triphenyl methane is an isolated PAH. It contains three aromatic rings. You can see here three aromatic. One is this one is this one, then two the benzene ring, and this is the third benzene ring. And this is all connected with a carbon. So carbon is having hydrogen also, because it is carbon should have 4 bonds. So 3 bonds it satisfy, 1, 2, 3 bonds connected with the benzene ring. So one hydrogen should be there. So I put this one hydrogen. So this is the structure of this triphenyl methane. So special point we can notice, it is a 3-ring system, right? We have already mentioned that it is a 3-ring system, and it is isolated because these rings are not fused, not attached on each other. So it is isolated because it is connected through a carbon. And this is the third ring. It's also connected through carbon and isolated. So 3 aromatic rings in the molecule. It contains 3 aromatic rings, 1, 2, 3 benzene rings. This is a special point of this triphenyl methane. So now let's see how it is prepared, how the triphenyl methane is prepared. So methods of preparation of the triphenyl methane. So triphenyl methane is synthesized by treating benzyl chloride. So benzyl chloride means benzene with CH2Cl and with benzene. So benzyl chloride, if we take benzene using a Friedel-Crafts condensation reaction. So Friedel-Crafts condensation always needed a catalyst, Lewis acid catalyst. So now let's see the reaction scheme. So this is a benzyl chloride, right? Benzyl chloride, this benzene having a CH2Cl plus 2 benzene. 2 molecules of benzene is needed because we need 3 aromatic ring in the molecule. One benzene ring is provided by the benzyl chloride, and other 2 benzene ring is provided by the benzene itself. So you treat with this Lewis acid. That famous Lewis acid is aluminum trichloride, right? AlCl3, and what you will get is triphenyl methane plus 2 molecule of HCl. So 2 molecule of HCl is gone, removed, and 2 benzene ring will be attached here. So the simple substitution or condensation reaction. So this is how you can prepare the triphenyl methane. The next method to prepare the same triphenyl methane using 2 molecule of benzene again and 1 molecule of benzaldehyde. So instead of benzyl chloride we can also use benzaldehyde. Benzaldehyde is a phenyl ring, benzene ring having a CHO group, right? This is aldehyde group. CHO is an aldehyde group and CO is a keto group. So benzene with aldehyde group is called benzaldehyde. So if we treat this two using the zinc chloride, this is also an Lewis acid, right? All the metal chlorides, and you will get this triphenyl methane plus water. In the case you will get water, in the other case you will get HCl. So these are the 2 methods we can prepare triphenyl methane from benzene and benzaldehyde or benzene and benzyl chloride. So now let's see. We have already seen the reactions of the isolated PAH using the diphenyl methane as the example. So we are not going to see any reaction, it will be the same reactions. Now let's move on to see about the fused ring system. So fused PAH, fused polynuclear aromatic hydrocarbon. We have seen this some examples also, and the important one is the naphthalene, right? It's shown here in this structure, naphthalene. So naphthalene, what is naphthalene? It's an organic compound, right? And it is a simplest polyaromatic hydrocarbon, because poly meaning more than one, right? And this is having a 2-ring system. So poly means more than one, polyaromatic means more than one aromatic ring. So this is the simplest one because it is contained the minimum requirement needed for a compound to be called as polyaromatic hydrocarbon. So this contains two aromatic rings or two pencil rings. So molecular formula is C8, C10, H10, H8, right? Calculate here and get the 10 carbon atoms in the ring, the two rings. If we calculate, if you count, you'll get 10 aromatic carbon atoms, and there are 8 hydrogen atoms also. 1, 2, 3, 4 here in this ring, and then 1, 2, 3, 4 in this ring. So total is 8. The structure consists of fused pair of benzene rings. That is a very important point. So that it is called as a PAH, yeah, polyaromatic hydrocarbon. So this is the fused ring area. The two rings are fused, right? It attached in this area. This carbon. This is fused. So chemical formula. This chemical formula of this naphthalene is determined very long back by Michael Faraday, a very great and very famous scientist. Michael Faraday discovered this chemical formula in 1826. So this is about the benzene. Now let's see about the physical properties of benzene. So naphthalene, right? So naphthalene is a colorless compound, right? It is crystalline solid, means it is very crystal shape, and it is a solid. And the melting point is 80 degrees Celsius, so it melts, it becomes liquid at 80 degrees Celsius if we heat it, and the boiling point, so it can evaporate at this 218 degrees Celsius. So this is a property about the naphthalene. As a characteristic order, so it is having a special order. You can see that naphthalene balls, we keep it in the closet, right? Keep it in the dress shelf to remove the odor, or also to avoid some cockroach and etc. So it is having a particular characteristic order. That's fine. So this is you can see this is a organic moiety. There is no, it's all hydrocarbon. So there is no polar groups, right? We have seen in the introduction there is no polar groups here. So this is not insoluble in water. Means not soluble in water. If you dissolve, it will not soluble, but it is soluble in some organic solids because it is an hydrocarbon or having only organic moiety. So it is volatile and sublimes on warming. So if a little bit warm, it will sublimes, means it will go to from solid directly to the gas phase, sublimation. So these are the important physical properties of the naphthalene. Now let's move on to set the chemical. What are the chemical properties of naphthalene? So naphthalene, these are some structural features of naphthalene. So naphthalene exhibit three resonance form, three chemical resonance structure you can get. So this resonance structure meaning, so it is having a same, the energy of the molecule will be same, but the structure having a slight changes. Just the movement of the where the double bond is present. This is called as a resonance. So energy, this is the same molecule. So say it is no, the reactivity will be same. Only the shift, double bond will be shifted. You can see it. So more if you are having a resonance structure, more stable is the compound. This is the general idea behind the resonance structure. So it contains three resonance structure or canonical structure, meaning 1, 2 and 3. You can see this is the first structure of the naphthalene. So it is having 5 double bonds, right? 5 double bonds, and if you please note where the double bond is. This double bond is here, and this double bond is here. This double bond here, this double bond here, and this double bond here. So if you draw the second resonance structure by shifting the double bond, if this double bond goes here, immediately this double bond will shift here, and this double bond will go here, and this double bond will go here, and then finally this double bond will go here. This is what it is happening here. You can see I draw this structure here, and this is the second resonance form or canonical. Again we can shift this double bond here, right? You can shift the double bond here, and this bond will go here like that. Then we can draw the next canonical structure by shifting this double bond from here to here, from here to here, and from here to here. This back. So this will get. So the three resonance structure is possible, or the canonical structure is available for the naphthalene. So this is shown in this three resonance structure, and all having the same energy. So there is no change in the energy, right? Energy of the molecule is same. So if you all are same molecule, same structure. Only the double bond is shifted. So there is no energy change. So now let's move on to see how the naphthalene is prepared. So in the naphthalene can be obtained from coal. So coal is so in India, for example, we are getting 80% of the electricity from coal, right? Coal burning of coal. So coal is a natural form. So it is a so we can obtain naphthalene from coal also. So when the middle or heavy oil fraction of the coal is chilled, so if you cool the middle portion of this coal, naphthalene can crystallize. We can obtain naphthalene. How? It is shown here. So coal, okay. So you will get the heavy oil fraction. If you chill that fraction, you will get some crude naphthalene. Meaning, naphthalene is not very pure at this stage. After that, we can treat with acid and base. First, we can treat with acid to remove some acid impurity away, and then treat with base to remove the basic impurity. Finally, you will get a pure naphthalene. So this is how you can get naphthalene from coal. Okay, so and you can see here this picture showing the coal, the process where we can get the coal. So this is how you can get from the natural resources like coal. This can also be obtained from petroleum, but there are some stages needed, several steps needed for getting naphthalene from the petroleum. How? Naphthalene can be prepared from suitable petroleum fractions. So if some suitable petroleum fractions are there, you can get naphthalene from them. Because the suitable petroleum fractions are passed over to copper catalyst. So if you pass the suitable fractions of the petroleum on the copper catalyst at 600 degrees Celsius, so it's need a high temperature, it can produce methyl naphthalene. So first you will get a methyl naphthalene. So this is shown in this reaction scheme, right? This is a this is the methyl naphthalene, right? This is methyl naphthalene we can get from the petroleum fraction by copper catalyst, and methyl naphthalene dealkylated to give naphthalene. So if you treat the same high temperature and if you add some hydrogen, so this is methyl naphthalene you will get from the petroleum, right? This is the first step, and then you add hydrogen, and this dealkylation means this is alkyl group. Dealkylation means remove of alkyl group. So you can remove the alkyl group and get the naphthalene from the petrol. So this is how you can get the naphthalene from petrol. First you will get this compound, and then you treat with hydrogen gas, and then you will get naphthalene plus methane. Methane is a gas; it will evaporate, right? It will go away, right? Methane is a gas, so it will easily can go away. So this is how you can get from naphthalene from coal or petroleum. So we can also see how the naphthalene can be prepared from chemical synthesis, not from the laboratory, because these are very difficult process, right? This from the coal and from the petroleum. This contain very difficult process involved, and a lot of other compounds also mix. So purification is difficult in this case from petroleum. So it is better to synthesize in the lab or prepare in the lab, so that we can bulk prepare the naphthalene and supply, because naphthalene is a starting material for many drugs, right? Many drugs and other making other chemicals and other useful chemicals. So this laboratory synthesis of naphthalene we will see in the next class. So this is so far for this class, and we will see in the next class. Thank you.